This video is exciting to me because for the first time, we're going to be using trigonometry in a triangle that's not necessarily a right triangle. So I'm going to first highlight or pay attention to the fact that we can use the following proportions in all triangles, not just right triangles. This is important because it's going to expand our ability to use trigonometry to solve problems. So the law of sines is expressed by the formula below. And what that really says is that we can write ourselves a proportion that compares the side length of any triangle to the sine value of its opposite angle. So in other words, recall that side A, represented by lowercase letter a, is the side that's opposite angle A. Recall that in any right triangle, side B, represented by lowercase b, is opposite angle B. And then lastly, side C is opposite or across from angle C. As honor students especially, you should understand how come this works. So we're going to take a look at a short proof of exactly why the law of sines works. And we've got this right triangle with altitude h drawn, where AB is the side that's the hypotenuse, and sides AC and CB represent the lengths of those legs. I'm going to say that if I first consider that blue triangle, I'm going to say that for that blue triangle, recall that the sine of an angle is the ratio between its opposite leg and the hypotenuse. So the sine of our angle B is the ratio between the opposite leg, which in this case is the height or the altitude of our triangle, and the hypotenuse, which is A. And I'm just going to go ahead now and solve that real quickly for h, and I get h is equal to A times the sine of angle B. I'm going to go through next and do the same thing for my purple triangle. Let me make that a little bit brighter, darker, so we can all kind of envision the purple triangle. In the purple triangle, I'm going to say the sine of angle A is equal to the length of its opposite leg, which in this case is the height or the altitude of our triangle, over side B. So again, cross multiplying gives us that h is equal to B times sine of angle A. Well, now I've got this nice system of equations here where h is equal to both of these values. I'm just going to do a little substitution now, and I'm going to go ahead and I'm going to make A times sine of B equal to B times sine of A. I'm going to divide both sides by sine of B. So when I divide the left side by sine of B, I'm just left with A. And I'm also going to divide at the same time both sides by sine of angle A. So on the left, I'm going to have divided by sine of angle A. On the right, the sine of angle A's will cross off, and I'm left with B over the sine of angle B. And of course, if I wanted to, I could draw my altitude in a different spot, and that would extend my proportion to allow me to be able to say side C over the sine of its opposite angle, angle C. So again, now we've derived this law of sines. The important thing to remember when using the law of sines is it always compares the side length to the sine of its opposite angle. We're always looking for those pairs of opposites. All right, so let's go look to see how we could use this to solve some problems. In example 1, it says to find the length of side B. I'm going to, just because we're new at this, I'm going to go label side A with a lowercase a. They've already in the picture labeled side B with a lowercase b. If I'm thinking about pairs and matches, side B is going to match up with its opposite angle, angle B. Side A matches up with its opposite angle, angle A. Side C matches up with its opposite angle, which is angle C. So when looking at this problem, I'm going to go ahead and I'm going to match up, because I'm looking for side B, I'm going to start by matching up side B with the sine of its opposite angle, 48 degrees. The only other side value that I know is this side C. So I'm going to go ahead and remember that in any triangle, the sum of the three angles has to add to 180, and that makes the measure of angle C 57 degrees, because now I can go write the second ratio in my proportion over the sine of 57 degrees. Notice that when I set these proportions up, I'm picking any two of the three, or utilizing any two of the three. So again, it's these three that make up my law of sines. I'm picking whichever two I can utilize based upon the information that's given to me in the problem. So I'm going to go ahead and I'm going to cross multiply b times the sine of 57 degrees going in one direction crosswise equals 12 times the sine of 48 degrees going in the other direction crosswise. So b, when I divide both sides by sine of 57 degrees, is going to be 12 times sine of 48 degrees over sine of 57 degrees. That would be, if I were asked to find it, an exact value. Notice that I can find that very easily and quickly without having to punch things into the calculator. This question, if I were asked to round to the nearest whatever, I would just punch this into my calculator. And let's suppose the directions specified to round to the nearest tenth. I would get my calculator out. I'd punch that into my calculator, and to the nearest tenth, I would end up 10.6. And I think I should include my units because they told me in the problem that this were centimeters. So again, a really nice illustration between an exact value, which you can find without using the calculator, and a rounded answer, which you plug into the calculator to find. All right, I'm going on to this last example, which says to find z. So again, if I'm thinking about those pairs in the matches, side z is going to match up with its opposite angle, which is 112. And looking at what else has been given to me in the problem, I have that 8 centimeters. So I'm going to look for its opposite angle, which I wasn't given, but I can just find very quickly by subtracting the other two from 180. Doing that tells me that the measure of angle x is 39 degrees. So I'm going to go ahead and set up my proportion. Side z over the sine of its opposite angle, which is 112, equals the 8 centimeters over the sine of its opposite angle, which is 39 degrees. All right, I'm going to go ahead and cross multiply. Z times the sine of 39 going in one direction equals 8 times the sine of 112 going in the other direction. So Z equals 8 times the sine of 112 divided by sine of 39 degrees. And again, if I'm trying to find an exact value, I'm going to stop right there and I'm not going to go any further. If the question specified for me to round, then I would punch that into my calculator. And let's just suppose this one too said round to the nearest tenth. That would be 11.8 when rounded to the nearest tenth. All right, and there it is, folks. There's law of sines, something that's going to kind of open some doors and let you go into some places with trigonometry that you haven't been able to go before. I think it's really exciting. It's really useful. And when you come to class, we're going to use it in some problem-solving examples. Till then, though, thanks for your time and attention. Can't wait to see you back at it in person again soon. Take care for now.